Welcome, everyone, and thank you for joining us today. I'm going to start off the day with a land acknowledgement. We acknowledge the land that we are meeting on is the traditional territory of many nations, including the Mississaugas of the Credit, the Anishinaabe, the Chippewa, and the Haudenosaunee and the Wendat peoples, and is now home to many diverse First Nations, Inuit, and Métis people. We also acknowledge that Toronto is covered by Treaty 13 with the Mississaugas of the Credit. Welcome everyone again, and thank you so much. My name is Dr. Eugenia Addy, and I am so happy to be here moderating today's event because I love science, and I hope after today, you will too. In 2016, the United Nations declared February 11th as the International Day of Women and Girls in Science to address gender inequity in science, technology, engineering, and math fields, also known as STEM. According to the UN, less than 30% of scientific researchers worldwide are women. So the UN wanted to help level the playing field. But the truth is that science needs everyone. The most passionate, the most curious, and the most ambitious people are of all genders, backgrounds, and affiliations. Making science more diverse and inclusive can only lead to new discoveries because people from different backgrounds and cultures think differently. And science is all about questions. Let me tell you how I became a scientist. It started off when I was very young, super curious, and super engaged. I always loved science, but never knew what to do with it or what it could do for me. It was thanks to my mom, my community members, and awesome teachers along the way that helped me put me on the path to science. Now I run an organization called Visions of Science because I love the idea of giving back to communities that I grew up in and sparking an interest for science in kids all over the Greater Toronto area. I want the students that we work with to know that they can do anything because science can help solve real world problems. But most of all, I want them to know that science is fun. But honestly, don't take my word for it. Watch this video.
Science isn't just microscopes and neurons and bacteria. It's a way of asking questions.
We are training the system to find a new path between the muscle and the brain.
Everyone has some connection to cancer. We need to find a way that we can prolong their life and give them hope.
Studying regeneration or using cells to fix broken hearts, that is something very new.
The brain is vast, the brain is complex. You want to kind of crack that code.
So what if that was a pandemic and the virus spreads really fast? We are predicting the future.
I was always interested in robotics. I love using technology to improve someone's experience.
Science is curiosity, and science is wanting to know more about the world. It's fun.
Hi everyone, it's Amy Poehler here, and I just wanted to join you in the education and empowerment of young women and girls and say that we all know role models are very, very important because when you see others like you who are scientists or engineers or doctors or astronauts, the hope is that maybe you'll see yourself in that too. And so it's important to discover and explore your potential. And so we love this event that the Kremble team has put together. They've put together this event for you today, and it's a sneak peek into the world of science and medicine. And I'm just here to remind you what I know deep down you probably already know, which is if you work hard and you dream big, anything is possible.
That is amazing. Thank you, Amy, for that incredibly inspirational message. It certainly resonates with me. Okay, We have a lot in store for you today, so let's get to it. To start us off, you are going to hear from some amazing scientists who are each leading in their fields of research, and they're going to tell you about what they're working on and their path to becoming a scientist. Then, after the presentations, our speakers will join me to answer questions submitted from students. Are you super excited to get started? Let's go. I would like to first introduce you to Dr. Tahani Bhakta, a vision researcher and crochet master with the Donald K. Johnson Eye Institute at UHN. Here is her story.
I started my journey not really a scientist. I started as a MD. I took 7 years in medical school and then finished some residency training. And during my work and my rotations in medicine and so on, I was always fascinated and excited by how these diseases on the cellular level develop. I studied molecular genetics at the University of Winnipeg. And from there, I gained a lot of skills on working in the lab, doing basic experiment, extraction, growing some cells. Blindness was one of the things that really got my attention when I was looking for PhD positions. It's exciting to get in the lab in the morning, especially when you're gonna start a new experiment. It's a lot of thoughts. Is your protocol gonna work? Are you going to find something new? I used a variety of tools, including pipetting cells, putting them in cell culture, putting them in an incubator, and then look at them under the microscope, stain the cells with different markers for different genes to see if our cells are growing well and surviving in the culture condition that we are using. The science that I do inspires me on everyday level. I'm also a mom for 3 kids, 2 sons and 1 daughter. They are really excited by the work that I do. When I have a presentation, I do my presentation in front of them and take their feedback. I even take them to the lab when I was doing my PhD, showing them my cells, trying to get them passionate and excited about getting into science as well. For crochet, it was a side hobby. I started by self-taughting myself through YouTube videos, basic stitches, then moving into making some toys for my kids. But afterward, when I started my master and my PhD, I was inspired by the cells that I see every day under the microscope. Crocheting models is not really easy. It takes a lot of time. Usually crocheting big models like brain or heart or liver usually take a month to finish. For small models like neurons, glial cells, it takes shorter, so in 2 weeks I can finish up this model. My designs are unique. I not find them anywhere really because they are made with a lot of knowledge about these cells, how they function, how they look like in real life. I love science, I love art, and I want to share my passion with the world on intersecting science and art together. Thank you.
Hi, my name is Tahani Bhakta. I'm so excited to be here talking to you today. I am a stem cell researcher and vision postdoc at the Donald K. Johnson Eye Institute at the UHN, but I do way more than just a science in a lab. I'm also a science communicator, a crocheter, a crafter, and a photographer. I have always loved photography, especially taking photos of the world around me, capturing the beauty in its purest form with all its details. The world is bold and beautiful. Just look at the colors in these photos. It's how they stand out. But unfortunately, not everyone can see those colors. Take a look at this photo. If you have normal vision, this is what you see. But if you have a vision disease called glaucoma, this is what you're gonna see. It looks like this. With glaucoma, your vision changes slowly over time. That's because there is a damage in the optic nerve in your eye. The optic nerve is the part of your eye that sends visual signals to the brain, and that's how you see. When you have glaucoma, initially you can see everything around you, but over time, your vision begins to narrow until all what you see is equivalent to looking through this tunnel. Imagine this. Unfortunately, also, currently there is no cure for glaucoma at this time, but researchers like me are working hard to find new treatment and maybe one day discover a cure for glaucoma. And this is my goal. That's why regular checkup and follow-up can detect the glaucoma early and slow the progression of the disease. Look at the picture on your left now. Here's what a normal eye looks like. But when you look at the right here, this is an eye with glaucoma. You can see that the pressure inside the eye is building up, affecting different parts of the eye and leading to damage and death of the cells in the optic nerve, right at the base of your eye. And inside the optic nerve, there is some neurons that are called retinal neurons, and they are the ones responsible for sending these electrical signals to your brain. If damaged, the eye can no longer send this clear picture to the brain. And once these cells are lost, they cannot be regenerated from within the eye. And here comes my role as stem cell researcher. To replace lost retinal cells, scientists like myself are growing stem cells, like the one you see here in the picture on the left side. Stem cells, they are amazing. They are shapeshifters. They can be any cells you want inside your body. When I was studying my PhD, I used stem cells to grow different type of retinal cells. And these cells can be then transplanted into models to test if they are functioning or not. Now as a postdoc, I'm going to grow retinal cells within a 3D system called retinal organoids. That's so exciting. I'm really excited for this project because it's going to be the first of its kind in Canada. If we were successful in our lab, we hope that we will be able to grow the type of cells that lost in glaucoma. And one day, perhaps, we will be able to transplant these cells into patients and save their sights. And this is why I come to the lab every day. My great passion is to communicate science with young people like you. And I love to do so using art. I use crochet to create neurons, retinal cells, even the COVID-19 virus. And by using these models, people can touch and feel and see, it helps open a conversation about the beauty of science, which is my goal. You don't just have to sit in a lab to do science. You can do many things instead. You can participate in science by writing, journaling, TV shows, and crafting. It's all about being creative and inspiring. Personally, I like going to schools and public events and using my crochet designs to promote science through art. But it's not only about science education, but there are many stories that touch everyday's life. I remember a lady who once bought my kidney crochet pattern to crochet a kidney for her husband, who was on organ transplant and on a waiting list and kidney dialysis for years. They wanted to keep the hope up and believe that miracle can happen one day. And after months, they contacted me and say it happened. And it was really a pretty good moment for myself because this is the reason I do what I do. We live in a wonderful world full of beauty. So just go out there, discover, open your eyes, look around you, feed your curiosity, ask questions, and learn new things. Learning new things is just as beautiful as the world around us. And the more we see, the more we learn. So just be creative, be both scientist and artist. And why not? For me, I always wondered if I want to choose between science or art, but now I know that being an artist makes me a better scientist. Thank you.
Thank you, Dr. Bakda. Science and art together, I love it. You don't have to choose. Our next speaker is Dr. Sindhu Johnson, a rheumatologist and clinical epidemiologist at the Schroeder Arthritis Institute at UHN. Dr. Johnson's role model is Dr. Roberta Bondar, Canada's first female astronaut, and an expert Girl Guide cookie juggler. Google it. Here is Dr. Johnson's story.
I was originally born in Montreal, and then we subsequently moved to Ontario and St. Catharines near Niagara Falls, and then eventually to Newfoundland. And as a kid, I always was curious, and I liked to learn new things. I can't say I was particularly in love with science in grade school, but I found it interesting. When I was in high school, we had the opportunity to participate in science fairs. Now, in Newfoundland, it was winter, and we typically put salt on the streets to melt the ice and to help people drive and walk more safely. And then that got me to thinking about, well, what are the other impacts on the environment of salt on the roads? If the salt is melting and goes into our sewer system, it could enter our waterways and the rivers within our city. So my first science fair project involved taking water samples in the springtime and testing its salinity. That is, how much salt is in that water. And lo and behold, I detected that river water had more salt in it than you would expect from a river in the middle of a city. I was able to present that project at the provincial science fair, and I won a prize, so that was exciting. When I was in grade 12, I had an opportunity to attend the Nobel Prize ceremony in Sweden. The Nobel Prizes are considered among the premier prizes in the world that can be given to scientists. Now, I have to admit, it was way over my head at that point, and I really didn't understand the science. But I do remember thinking, wow, like whatever science they are studying, it is clearly impacting the world in a very important way. And wouldn't that be really great if I could do something that would help other people too? So that's when I decided, okay, in my life, I wanted some kind of career that would help people and use science. And then that's what led me to medicine. What I love most about science is working with different teams of people. Sometimes people think that being a scientist is that making an individual discovery, having a eureka moment. But the reality is science doesn't work that way. Science is a team sport where I might make a discovery, but then you might make a discovery based on my discovery. And then the next person will add to that discovery, and we keep adding on each other's work until we get to the answer we want. The world needs more scientists. So please don't count yourself out. You are the next generation. You guys are clever, you have access to more information than any generation before you. And so I'm hopeful that you will consider making the world a better place and consider using science as a tool to achieve that goal.
Hello, everyone. Thank you for having me. My name is Dr. Sindhu Johnson. I am a rheumatologist. That means I'm a specialist doctor who takes care of people with arthritis. I'm also a scientist. I'm a particular kind of scientist called a clinical epidemiologist. Being a scientist or a researcher is like being a detective, and that's pretty cool. Whether I'm trying to find a new treatment or find a cure, what I'm really doing is trying to put the pieces of a puzzle together. I often feel like I'm on an episode of CSI or being like Sherlock Holmes or Enola Holmes. If I put the pieces of the puzzle together, if I do it right, I will solve the mystery. Now, in our body, we have bones that come together to form our skeleton. When two bones come together, we call that a joint. Sometimes people can have pain or swelling in their joints, and that could be a sign of arthritis. Now, there are over 100 kinds of arthritis. So when a patient comes to see me with pain or swelling in their joints, my job is to try to figure out which type of arthritis they have and what is the right treatment for them. Now, arthritis can affect people in different ways. People can have pain or swelling. People can have difficulty walking, running, climbing stairs, dancing, keyboarding on their computer, or even holding a pen to write. It can really affect people's quality of life. Now, people often think arthritis only affects older people, but that's not the case. Sometimes it can affect young adults, teenagers, or even kids. Arthritis is a mystery because we don't 100% understand what causes it or always how to treat it. Now, I specialize in an arthritic disease called scleroderma. This is a disease where the immune system attacks not only the joints, but can attack other organs in the body, like the heart, lungs, kidneys, just about anywhere. And so, as a scientist, I work with other researchers and with students to collect data or to collect information. And we are trying to find better treatments and ultimately a cure. Now, the first step in the scientific process is to ask questions. Often the questions come from the patients that I see. Sometimes they'll ask me, why did this happen to me? Was it something I ate? And so the first step in our science is to look to the literature and see what do we know about this already. So one of the students who's working with me, her name is Hannah, she did just this. And she found that yes, there are chemicals and minerals that are in our environment or that people can be exposed to as part of their work that can cause scleroderma. Another project that a student, Jennifer, worked on with me is to see what can we do to help people work. Many patients have told me that they want to work, but because of their arthritis or their disease, they can't. And what can we do to help them keep working? So in Jennifer's project, she found that the fatigue that comes with the disease can sometimes affect people's ability to work. She also found that being cold at work or at school can trigger a flare of the disease. So if we can find ways for people to take breaks, to share the workload, to have flexibility in their schedule, these may all be tips or accommodations that can help people continue to go to school or to continue to work. Now, doing research is not easy. It is a step-by-step process. First, we have to discover a treatment. Then we need to test the treatment in studies, sometimes called clinical trials, to make sure that the treatment works. And we also want to make sure that the treatment is safe. Now, I am proud to say that I have been part of the team to discover 2 new treatments for scleroderma. I went into the field of rheumatology because scleroderma is a disease that can affect the quality of life. But I've also come to appreciate that science is the only way that new treatments and cures are ever discovered. So, if you're good at putting pieces of the puzzle together, then maybe you'll advance the field and solve the mystery and ultimately find a cure. What could be better than that? Science is all about passion and curiosity. Thank you.
Thank you, Dr. Johnson. I agree. Science is all about passion and curiosity. Our last speaker this morning is Dr. Mary Pat McAndrews, a clinical psychologist and cognitive neuroscientist with the Krembel Brain Institute at UHN. Dr. McAndrews also loves traveling. She once took a hot air balloon ride over the Valley of Kings in Egypt. Let's hear more about her science journey.
Did I see myself as a scientist in high school? No, I definitely did not see myself as a scientist in high school. I don't think if you'd asked 16-year-old Mary Pat, would she be sitting here and having a conversation about the work she does in memory and with patients with epilepsy or Alzheimer's disease? I really don't think I would have imagined myself there. I actually had a very different career path in mind when I was young. I very much wanted to be a lawyer, as a matter of fact, and went to a school where I was preparing myself for legal studies. I found those pretty boring very quickly, and I had the great fortune to be able to work as a research assistant with a wonderful young professor who is just starting out in psychology and just building her lab. And I immediately fell in love with the kind of questions that we were asking there. A life of a scientist is exciting in very many ways. Excitement in the sense of I'm able to both learn totally new things, discover new things. But science is also a little bit tough in the sense that you're often having to hear criticisms of the work that you're doing because none of us does everything perfectly. The most important thing was to have really good mentors along the way who let you know that the journey was what was the important thing. My postdoctoral supervisor is now 103, and we were able to celebrate her birthday on a Zoom call last July. So that kind of makes me encouraged that hopefully I'll be able to kind of continue on in the journey of science for some time to come. The best life lesson I've learned in science is to be always curious, because that does fuel your energy and your enthusiasm for what you're doing, and to balance that curiosity with a good deal of grit, and that is the ability to kind of merge your passion at what you're doing with the ability to persevere when things look a little bit rocky or too tough. I certainly don't think I would have imagined myself as a scientist at 16. Now, it makes perfectly good sense to me that this is where I ended up. And I think even if a person doesn't see this as a career for themselves, your experiences will shape you in that direction.
Okay, good. We'll try the next one.
Hi there, I'm Mary Pat McAndrews. As Eugenia said, I'm a scientist and a clinical neuropsychologist at the Krembil Brain Institute. I study memory, specifically how the brain works to help you remember things and what happens when brain structures that support memory are damaged. Today, I'm going to be talking to you about my very favorite brain region, the hippocampus. On the left, you see how it would look inside the human brain. And on the right side, it shows you how it got its name. Hippocampus is actually Greek for seahorse, and the hippocampus is truly the workhorse of our memory. Now, I don't know about you, but some of my very best memories involve travel. I've been so lucky to see awesome places like the Serengeti Plains of Tanzania, temples in Cambodia and Thailand, and the beautiful island of Capri in Italy. And I've had really cool adventures like hot air ballooning in Egypt, snorkeling in the Indian Ocean, landing on a glacier in New Zealand in a helicopter, and dancing with the crew of our Nile River cruise. So how might memories like this be depicted or stored in our brain? Well, you might think of the brain kind of like a scrapbook, where someone with a healthy hippocampus could recall details of an experience like this one, visiting the Great Pyramids of Egypt in great detail, feeling the heat of the desert, the sand, the coolness inside the pyramid, seeing camels in the distance. But what might that kind of memory be like for somebody who has damage to the hippocampus? Well, our patients describe it as kind of blurry or vague, or sometimes like a sketch without any kind of colorful detail. And in the worst case, it almost seems like not even their own memory, seems like a story told by someone else. Now, when we started studying this about 15 years ago, no textbook was describing this kind of memory problem. And so we decided to take it on and try and figure it out ourselves. So here's a picture of the brain. You can see where the hippocampus is situated. It's kind of deep inside, and there's one on each side. But how can we better understand what it's doing? Well, one way is to look at people with damage there, like happens in Alzheimer's disease, or in people whose seizures from epilepsy cause damage in that structure. Another way is to use a special type of brain imaging called a functional MRI. And that kind of scan lets us look inside the brain at activity when people are remembering events. And our lab uses both strategies to study this. Oops. So this image actually shows us the results of a functional MRI study. On the left is a person with a healthy hippocampus. And you can see those bright colors in the hippocampus show that there's very much activity while they're remembering memories from their own scrapbook. And on the right is somebody with an abnormal hippocampus due to epilepsy. And here the activation is actually so faint, it's pretty much gone. We can barely detect it. Now, we've studied this in many different patients, and we always see exactly the same thing. And that is weaker activity in the hippocampus when they're remembering these events, and a really poor or impoverished memory, vague or blurry. They can't really recall those same kinds of details that for you and me allow us to have that memory come back to life. And now what we're trying to do is to study other real world consequences of that. So can you imagine what might happen if you can't bring up the past in order to understand the current situation or even to predict what might happen in the future? So I've been talking to you about activity in the hippocampus, but this kind of scan just shows you what's happening on average over about 10 minutes of remembering. But the brain is much more active, as we're showing in this video. Those nerve cells are communicating very rapidly between different regions. And so the last bit of our kind of research I'd like to talk to you about is what we've been looking at for brain cells, those hippocampal cells in Alzheimer's disease. So one thing we know is that very, very early on, even before we can detect the disease clinically, the activity in the brain, in the hippocampus specifically, is very high, like you see on the left side. And then as the disease progresses, it becomes slower and slower and milder, as you see on the right side. So we're trying to figure out if we can treat both sides of the coin there with a medication that might suppress activity in the very early stages, and in the later stages with a type of electrode directly inside the brain that might actually be able to help increase the activity that we see there. You can kind of think of it as a thermostat approach. Too high, you turn it down. Too low, you turn it up. Of course, your brain isn't like a furnace, and so we're really very early on in trying to understand what's happening there. Now, one of the great joys of my work is actually training the next generation of scientists. I love seeing my students present their ideas at conferences. Of course, it's not all hard work. We actually try and have some fun outings together as a lab. And we particularly love celebrating when one of our team manages to finally finish that PhD degree. In addition, we feel really passionately that we have to advocate for science in general, because that's the way that we're going to be able to have new discoveries that help us get past our problems and pressing issues in health, in climate, and everything else. So now, how do memory research, mentoring students, and travel fit together in my life? Well, let's go back to my scrapbook. So here's Donna. She's an early PhD student of mine who arrived from New Zealand to do her studies in memory with me. And here's Donna 15 years later as a full professor back in New Zealand. And as I said, I love travel, and I was really lucky that Donna invited me to give a special lecture at her university so that I could then experience all the glory of the beaches of the North Islands of New Zealand and the beautiful vistas of the mountains in the south. Now, you might not think a research career is your cup of tea. I certainly didn't when I was in high school, but now I cannot imagine a better life. It's full of adventure and reward. In the lab, trying to put together pieces of the puzzle to try the next adventure, in trying to help patients to live better lives, and in the amazing interactions that you have with students and colleagues. So I would encourage each of you to think of science as a potential career. And I also hope you can build your own scrapbook full of wonderful memories along the way. Thanks very much.
Thank you. And that's right. Follow your path wherever it leads you, maybe to New Zealand one day, if you're lucky. We have one more surprise for you today, a message from Gitanjali Rao, a young scientist and entrepreneur. Gitanjali was chosen as Time Magazine's first ever Kid of the Year in 2020 for her many inventions, including a device and app which she designed that tests for lead in drinking water.
Hi everyone, my name is Gitanjali Rao. I'm 16 years old and I'm an aspiring scientist, innovator, author, STEM promoter, and most of all, a student. I was honored to be named Time Magazine's first ever Kid of the Year. First of all, when you look at me, I don't look like your typical innovator, but I'm here to share that that's okay. Innovation doesn't have a specific appearance tied to it. Now, on this International Day of Women and Girls in Science, I want to share that no matter where we're from, what we look like, and how old we are, innovation needs each and every single one of us. I'm a strong believer that the driving forces of innovation are both empathy and curiosity, and that's something that we all have. if we all try to recognize problems like mental awareness, degenerative diseases, and look to ways that we can alleviate these problems, we can all make a difference in the society around us. We're slowly entering these interesting times, right? Where we're seeing things like personalized medicine. And these new technologies are shaping our future every single day. And I think that we all have the motivation to solve these problems around us. So, what I want to say is keep believing, keep dreaming, and keep being the empowering human being that you are. Because each and every single one of you have the power to be a change maker. If I can do it, you can do it, and so can anyone else. Thank you so much for your time.
Wow, that's amazing. Thank you, Gitanjali, for that inspiring message. It's now time for our Q&A. So I'll welcome all of our speakers back to join me. And I have to say, we received some really insightful questions from students. So I'm eager to get started and dig in here. Let's start with a question from a class at Queen of Heaven Elementary School. They'd like to know, what can young women do to prepare and explore careers in STEM? Dr. Bhakta?
Yeah, so that's a great question, really. So I would advise or suggest that girls interested in STEM career or any like science, joining any science field research, to reach out to their science teachers. They are the first one to really touch with. Show them your interest in science and ask them for available resources at the school itself. And then you can really head up and join science club in your school or at any university in your area. Volunteer in science fairs and events, and all of these gonna help you to build up a network really that will guide you throughout the way until you find your passion.
I agree, Dr. Bhakta. I know for myself, it was really important to just try everything. And that's what I would encourage a young woman to do. When you're interested in something, the internet, Google it, get connected with incredible professionals in the field like Dr. Bhakta, Dr. Johnson, and Dr. McAndrews. Attend awesome events like this. And if possible, try and really look for opportunities where you can actually try it out. That's kind of what made the difference. Amazing. Okay, next we have a question from Madame Sangmail's class from Bloordale Middle School. If there were one or two teachers who had a huge impact on your career and life today, what words of encouragement did they give you that you can share? First to you, Dr. Johnson.
Oh, sure. Thank you. I would love to give a shout out to the teachers. I have been blessed with many great teachers over the years. But to answer your question, there were two teachers that stand out in my mind. First was Mr. Roy Anthony. He's a teacher in St. John's, Newfoundland, and he ran a club called the Young Scientists of Canada. And this was a club that you didn't have to be just at one school. Any high school student could join. And so through him, I learned that science can be fun, that science is cool. And that through his club, I learned that science is a way of unifying people so I can have a group of friends and that we can do fun things together and work towards goals together. And many of these friendships have lasted many years. So I'm very thankful to Mr. Anthony for teaching me that. The second teacher that's important to me is Mr. Kevin Lewis, and he was my high school drama teacher. And I've come to realize now that although it's important to study the sciences to be a scientist, the arts are equally important. And so when I was in grade 10, I saw how a disease affected the lives of the people that he loved, his family. And at the time, I didn't understand the disease, but I could see here was a teacher that I really admired and that was being stoic, but suffering. And that stayed with me for many years. And I'm going to come back to that in a moment. But through drama, I learned, but true of all performing arts, is that I learned about how to communicate, and I learned about mustering up courage to be on stage and to give a talk or to perform, and the importance of engaging an audience. And so I think the performing arts and the visual arts are equally important to the conduct of science. And so when I say I'll circle back, I said to you that I'm proud that I was part of the team that discovered 2 treatments for scleroderma. And this treatment is used for people who have lung disease called pulmonary fibrosis. And so when Health Canada finally approved these 2 treatments for the Canadian market, I thought of these 2 teachers, and I hope that someday they will know that they helped my journey to get there.
Thank you, Dr. Johnson. Dr. McAndrews?
Sure, I'd love to take a crack at that. Thanks, Eugenia. Very much like Sindhu, I've had the benefit of amazing mentors and also clubs of science geeks to hang out with. So I think we've all benefited from that. But one thing that really stuck with me, I was a young research assistant in university to a new professor, Dr. Darlene Howard. And I was charged with running a big statistical analysis. Now, this is back in the day, I'm going to age myself here, before people had personal computers or anything like that. So we actually had to take over the university computer overnight to run this analysis. And the next morning, I realized I had made a big mistake in the code, and the results were total junk. And I thought, okay, here's the end of my career. I'm going to have to go to my prof. She's going to say, get out of my lab. This is terrible. She's going to hit the roof because I failed in what my task was. And when she sat down with me, she actually told me that mistakes are not failures. We all make them all the time. And that the real failure is not taking an opportunity to learn from those mistakes, so that you can grow and develop and make sure that you're kind of on the right trajectory. And I hope that I carry that through not only in my work these days, but also with my trainees. So we all know that we never make exactly the same mistake twice, even though occasionally we might make another one. But that stuck with me as such an important lesson, both for myself to kind of keep trying. And the only mistake that you make is to not try it a second time. So that sticks with me. Thank you, Dr. Howard.
Thank you, Dr. McAndrews. That's some really great advice. We also have a question from Miss Dahal's classes from Amesbury Middle School. They ask, what were the greatest challenges you faced as a woman or as a woman of color in your education and employment? And how did you overcome them to succeed? I'll first ask Dr. Vakta.
So my question gonna be like, my answer gonna be like, things have really changed since I did my high school like 28 years ago, about 28 years ago, yeah, to be exact. But back then, choices were limited for girls who want to choose science major in the school. They had only two choices. If you choose a science major, you either be like a teacher or a doctor. There's no other possibilities. Like basic and clinical research weren't popular choices by that time, for girls at least. And there were also like few or sometimes no examples at all for young girls to follow or to get inspired with. And also community understanding and supporting of such idea of girls being in research wasn't like that much appreciated. I mean, and STEM organizations that was supported girls to get into such a science field were really few, and resources as well. So girls interested in higher education and science had to figure it all by themselves. And also like being inspired or being inspiring models to the next generation. And that's what I wanted to do. Like I wanted to continue my higher education and my graduate studies and be an inspiring models for girls from my country to pursue a science career.
Amazing. Thank you, Dr. Bhakta. I'll also answer that question. I think for myself, one of the most challenging, the greatest challenges I faced was feeling unseen, literally not seeing myself reflected in the textbooks I was reading, and many of the television shows I was watching. And it was really hard for me to actually imagine that I could be a woman in science, let alone a Black woman in science. I know that as I grew older and I was able to engage and interact with representative role models, actually talk to people in the field and engage with them, it completely changed my perception of what I could actually do. It also changed my perception of employment options. I also just didn't really know that there were so many cool careers that you could tap into by simply staying on the pathway to STEM. So many TV shows kind of depicted like mad scientists, white hair, looking crazy in a lab. And I just didn't want to be that. So now that I can see that there are so many incredible careers, and some folks will do that, but there's such an open world that you can kind of tap into. You can travel the world, as you heard from Dr. MacArthur. You can be a like a CSI agent. You can do so many different things. So I think when my world was opened up to it, my possibilities started opening up, and my community was able to kind of rally around me to make sure that I was able to seize those opportunities. So that was really important. Okay, we have another question from Madame Shirk's grade 7-8 class from Jeune Sauvé Public School. And they have a question for Dr. McAndrews. Why did you choose to focus on memory research?
Great question. We have, like many people, I had a personal connection to Alzheimer's disease. So my grandmother, who'd lived with us throughout my whole childhood and adolescence, developed Alzheimer's disease and finally had to go into a supported living facility. And I vividly remember visiting her one day there, and she was unable to remember who I was, someone who'd known me my whole life. And I figured that actually understanding how memory works in the brain might get me a little bit closer to understanding such diseases, and maybe eventually to being able to develop better tools for diagnosis and for treatment for those diseases. So both the questions were intellectually stimulating, but I'm not sure I would have gone there had I not also had that kind of personal connection to that particular issue.
Awesome. We have another question from Madame Shirk's class, and this question is for Dr. Johnson. They'd like to know, which one of your discoveries do you think has made the biggest impact in medicine?
Oh, I would say that being part of the team that developed the 2 new treatments for scleroderma are pretty big achievements. You know, when I started practicing 15 years ago, or more than 15 years ago, I really didn't have options. And so it was a very sad conversation that I had to have with patients, saying that we're now coming to the end of the line. But the ability to have 2 more options means that we can prolong life, and we are one step closer to finding a cure.
Amazing. It looks like I'm up next. Miss Elliott's grade 6-7 class from Lincoln Avenue Public School would like me to answer this one. Can you provide a concrete example of how your work encourages people to consider STEM? I can. I know that, as you know, I run an organization called Visions of Science, and we work with youth and to engage them in really meaningful opportunities in science, technology, engineering, and math. I remember one of the youth that we work with and have worked with for a very long time actually came to one of our programs when they were in grade 5. Since then, we've been able to work with them over the years. They went from being sort of interested, sort of shy, not really knowing if they liked it, interested in a whole bunch of different things, which was amazing, to now about to graduate and enter a STEM field in, I think they want to go into quantum physics, which is really, really interesting. That's the goal and that's the pathway. So from somebody who wasn't too sure to somebody who's super and wants to make a change in that area has been really awesome. This individual also just recently got a really awesome scholarship to University of Full Ride Scholarship. So that's just one example of the incredible youth that we get an opportunity to work with and we get to encourage on the pathway to STEM. I hope that answered your question. Dr. Bakda, Miss Angel's class, Engel's class, grade 5-6 from Lincoln Avenue Public School, has a question for you too. You've accomplished so much in your short career. Do you have any advice on how you get all of this done?
So just to comment, I don't think that it's a short career really. I have been doing science for more than 20 years now after graduating from medical school. So I think the biggest and important thing to have is to have a dream first. Just imagine what you want to be or the path you want to go through. And after that, you can just try to build around you like this support system. So during my my MD years, my dad and mom were my best support system. I mean, they kept me focused on studying and made everything available so that I can achieve my dream and my passion. And during doing my master and my PhD, I mean, of course, my supervisor supports were the most important things, but in addition, like physically and mentally, my husband and my children like supported me a lot in order to also get these degrees and achieve my goals. So just work on your dream and put your eye on it and you're gonna get it.
Amazing. And thank you for that lasting advice. That was great. Let's do a quick round of would you rather before we wrap up. Dr. Bakda, would you rather crochet or bake?
That's a hard question, really. I like both.
Yeah, you gotta pick.
Let's say bake because I like to make a lot of cake and tarts and pies for my kids. So in my always like every day on everyday basis on events and celebration as well. So yeah, I'm gonna be baking for this time.
Okay. Dr. Johnson, would you rather have dinner with Nobel Prize winner Marie Curie or former First Lady of the United States, Michelle Obama, or Roberta Bondar? Very hard.
Oh, I would just love to have a dinner party with all three. But yeah, no, I would have to say Roberta Bondar. I'm a girl. I was a girl guide. I'm now a girl guide leader for my daughter's troop. And she too was a girl guide. And as you mentioned in your introduction, she took Girl Guide cookies with her to space. And there's a famous photo on the internet of her juggling these cookies in space. And so I think if we had dinner together, I would be asking her all about that.
Got it. Dr. McAndrews, you seem to really love adventure. Would you rather go skydiving in Fiji or scuba diving in the Great Barrier Reef?
Oh boy, that's really tough. I've been to the Great Barrier Reef, luckily, and doing snorkeling. And scuba scares me just because I don't want to depend on something else for my airwaves. So I think I would have to say skydiving. And I probably would want to have 2 parachutes or maybe even 3, just in case.
Okay. Before we go, I just wanted to ask each of you for one last piece of advice for students watching who may be interested in a career in STEM. Just one sentence or two. Dr. Johnson?
Do your best, forget the rest. You've got it.
Love it. Dr. McAndrews?
Sure. My piece of advice is to cultivate curiosity because sometimes we just get satisfied with getting the right answer. But the real thing is for science is kind of ask the next question. So cultivate that curiosity.
Amazing. Dr. Bakda?
My last advice for everyone is just experience and be open to everything. Explore different fields and focus on what interests you.
Amazing. I hope everyone took that advice in. That's all the time that we have for questions today. Thank you so much to everyone who joined us. We hope you enjoyed the talks, and we especially hope that you leave feeling inspired and excited about your future. There is so much to explore and discover, and this is only the beginning. Thanks as well to the Kremble team, Carly McPherson, Heather Sherman, Twain Pereira, and Amy Ma for organizing today's amazing event. And a big thank you to our speakers, Dr. Bhakta, Dr. Johnson, and Dr. McAndrews. You all did a great job. A quick reminder that today's event was recorded, and you can access the recording with the very same link that you logged in with today. Feel free to pass on the link along to anyone that you think may be interested. And finally, remember that we can all make a meaningful contribution to our community and to our society. So follow your passion, ask your questions, and stoke your curiosity. Don't ever forget that science needs you. We need all of you. And be well and stay safe, everyone. Thank you so much.